This video is going to look at the inverse sine function, and just for notation purpose, if we recall when we talked about our inverse functions before, remember we would have our function f of x, and then the notation we put a little -1. This is not the exponent, but this would stand for the inverse function of f. Okay, so that's what we're looking at here. This would be the inverse for f of x. So here we're looking at the inverse function for our sine function. So before, up to this point, we would have y equals, let's say for an example, sine of a negative pi over 2. And at this point, we would look at our unit circle, and we know that it's a negative pi over 2, so we would be here at the bottom of the circle because we're going to rotate downwards because of the negative. Of course, up here at the top would be a positive pi over 2. And for the sine function, we would say, well, at negative pi over 2, we know the coordinates here are 0, -1, and therefore the answer would be -1 because our sine function is looking at the y value. Okay, so that's what we've done up to this point. This is our function. So now what we want to do with the inverse function is, if you notice in this example, we were taking the sine of an angle and we were finding the sine of the angle, which is the y value, to be a -1. Well, now what happens if we have the sine of some angle theta and they tell us the sine of that angle equals a -1? So in this case, what we're trying to do is we want to find the angle. Okay, and we want to find the angle that has a sine that is equal to -1. Okay, so this is where we're actually going to use the inverse function, the inverse sine function. So let me rewrite this. We have the sine of theta equals -1. So the way that we would do this is we want to take the inverse sine. So we would take the inverse sine of the sine of theta. And if we do it to the left side, we have to do that to the right. So we would take the inverse sine. So this sine to the -1 represents the inverse sine. And that would be the inverse sine of the -1. And on the left-hand side, the inverse sine of sine, they're going to cancel each other out. So here, when we do this inverse sine, we're simply going to be left with the angle theta. So then we have the inverse sine of a -1. And we'll talk about a little bit more what this means, but the inverse sine of -1, that means when our y value, okay, again, this is the inverse sine, so we know that this here, we're looking at, if we have a y value here, this -1, what angle has a y value of -1? Well, we just looked at the example above. We can see right here, if we're down here at the bottom of the circle, our y value is a -1, and we could use this negative pi over 2 as our angle. Okay? And of course, you may be asking the question, well, why do we use negative pi over 2? Couldn't we go all the way around the circle, for example? If we started here and went around this way, couldn't we use a positive 3 pi over 2? And that would put us here at the exact same location. And that's true, but I want to look at and explain as we go through here and explore the inverse sine function why the negative pi over 2 is one of the angles, or what we're going to get when we use this inverse function, because there's going to be some restrictions that we have to put on this inverse sine function when we use it, and we'll look at that in just a few minutes. So of course, the angle here, if we were to take the sine of 3 pi over 2, we're also going to get a -1. But when we start using this inverse function, there's some restrictions so that when we use it, it's actually going to give us an answer of the negative pi over 2. So let's look at that now and investigate where this inverse function is coming from. And to do that, we want to go back and look at first our sine function. So let's go back and look at the sine of x. So we want to pull up the graph of sine of x, okay? Make sure again your calculator is in, we're using radians, so it's in radian mode. And I'm going to hit zoom 7 to go to zoom trig. And now we need to think about when we have a function, what were some of the things we talked about when we were talking about functions in the past? Back in your pre-calc 1 class, we talked about if we have a function, we said that in order for this graph to represent a function, it would have to pass a vertical line test. So this certainly passes, so therefore it is a function. And we said if it has an inverse function, do you recall that we had a horizontal line test, which said if we draw a horizontal line, it should only touch the graph once. Well, certainly if I draw a horizontal line here, it's definitely going to touch the graph or cross the graph more than one time. So that tells us this function is not one-to-one. Well, if the function is not one-to-one, we cannot have an inverse. So this is where we have to restrict the domain. Okay, so this is where the domain and range is going to come into play. We need to restrict the domain and the range so that we have a one-to-one function. So how could we restrict this graph so that when we draw a horizontal line, it's only going to cross the graph once? Okay, and keep in mind, let me label here, we're going from 0 to 2 pi, and this would be pi over 2 pi. This point is 3 pi over 2. And if we go to the left, this point here would be negative, this is a negative pi over 2. This would be negative pi. And of course, all the way over here, we'd have negative 3 pi over 2 and a negative 2 pi. So where could we restrict this graph? So you may think about that a little bit, but where we want to do is, if I was to start right here and look at the graph from here to here and stop, notice the graph is going up to a positive 1 and down to a negative 1. So by restricting the graph from this little part here that I've drawn here in purple, notice that the range, we're still going to get out all the values from negative 1 up to a positive 1. So therefore the range is negative 1 to positive 1. Okay? And then if we look at the domain, that's our x value. Well, notice here the x is going from a negative pi over 2 to a positive pi over 2. So therefore the domain, we're only looking at angles from negative pi over 2 to a positive pi over 2. And that's why briefly, I'll go back up here. That's why up here in this example, why I was using this negative pi over 2 instead of the 3 pi over 2, because in order for us to have an inverse function, we have to restrict the domain. So the best way to restrict the domain is negative pi over 2 to positive pi over 2, because by doing it here, we're able to get out the entire range, because the range was always negative 1 to 1. So now instead of having the domain all real numbers where we would get the entire graph, we're going to restrict it from negative pi over 2 to a positive pi over 2. So now if we look at this middle part here that's in purple, we can certainly draw a horizontal line anywhere, and it's only going to cross this middle part of the graph in purple one time. So we now have a function that is one-to-one. So when we think of the inverse function, y equals the inverse sine of x, then what's going to be the domain and range here? Well, the domain, well, it's going to be reverse of what we had up here. Remember, we're going to switch our x and y values. So our domain is going to be negative 1 to 1, and the range is going to be negative pi over 2 to a positive pi over 2. Okay, and that's why the way I kind of visualize this, now be careful, this is not the graph of the function, but visually when I think of the unit circle, I think of the range that we're getting out here. I think of this as going from negative pi over 2 all the way up to a positive pi over 2. So I think of this as we're looking at angles that are in the positive first quadrant or that are down here in what I would say is the negative fourth quadrant. And it's the negative fourth quadrant because we're going down. So we're only going to be able to look at or get out angles within the positive first and negative fourth quadrant. Okay? Now, of course, if we were to look at the graph of our inverse sine function, then the graph of this function, let's see if we go to the calculator. If we go to y equals, I'm going to clear out the sine function. And this is where you'll notice now on the calculator, if you look above the sine key, you see a little sign to the negative 1. That's your inverse key. So if I was to type in second sine, so now we get this sine to the negative 1, and that doesn't mean negative exponent, but that's the inverse sine of x. And we look at the graph, and again, I'll go to zoom trig. Here we have the graph of our inverse sine function. Now, at first glance, this looks a little bit like a straight line. It's a little hard to see, but if we try to zoom in a little bit, let's see if that'll help. If I hit zoom 2, and I'm going to zoom in right on the origin here, right in the middle of the graph. And that may have zoomed in a little too much here. Okay, so you can see here that the graph is actually having a little bit of a curve like this. And I'm actually just going to draw this over here to emphasize this a little bit better. So what we have with this graph is we're going from here to here. The graph is really looking something like this, where we start here and it's going to have more of a curve going this way and then up like this. So this is your inverse sine function. Okay, so I'll kind of curve it this way. And the reason that's the case, if we were to look at the graph of the sine function, notice here how it curves this way. So the the sine function would go kind of like this. And remember that our function in inverse function is always going to be a reflection about the line y equals x. So if we were to draw the line y equals x through here, it would be a reflection here. So this is kind of the basic graph of your inverse sine function, okay, where this would be going up to pi over 2 and down to a negative pi over 2. And then, of course, the domain would be negative 1 to positive 1. So once again here, notice we are switching the domain with the range. Oops. So that is the inverse sine function. And the part that I really want to emphasize once again is realizing that we had to restrict up here the domain of our sine function. So make sure you really understand this. We have to restrict this domain from negative pi over 2 to a pi over 2 so that we will have a one-to-one function in order to have this inverse sine. Now I do want to mention some notation here. If the notation using the sine to the negative 1, y equals the inverse sine of x. Now there's an alternate way that we could do this, or we could write it as y equals what we call the arcsine, and that's abbreviated ARCSIN of x. And these two things mean exactly the same thing. Okay, it's just simply two ways of writing the inverse sine. And throughout the book and throughout the lectures or throughout the problems you're going to see, sometimes you're going to see it written here as the sine to the negative 1, and other times you're going to see this written as arc sine of x. Once again, it's just two ways of writing the same thing. It's kind of like when you learned multiplication, you used to write it as 2 times 3 is equal to 6, and then we started using a little dot, 2 times 3 equals 6. So there's two ways of writing multiplication. So here there's just two different ways that we're using to write the inverse function. So for an example, we could write the arc sine, I'll use this notation, of 1/2. Or once again, we could have said, what is the inverse sine of 1/2? So either one would mean the same thing. Well, if we want to find the arc sine of 1/2, then what I always tend to do is look at the circle. Okay, now again, what you need to remember is when you're using this arc sine or inverse sine, remember we're looking for the angle. Okay, and if it's the arc sine, the first thing I do is I mark off and say, okay, I know that we're looking from a negative pi over 2 up to a positive pi over 2. So I'd actually probably normally draw it kind of like this, knowing that this is the only set of angles that I'm looking at when I use this arc sine, and that's due to the range, what we can get out of the inverse or arc sine function. Okay, the only angles we can get out would be negative pi over 2 to a positive pi over 2. So here you could go to your unit circle now, and we want to identify the sine function. Now that means our value here at 1/2, this is representing our y value, right? The sine function deals with y, the cosine is x. So where on the unit circle do we have a y value of 1/2? Well, because we're only looking in the first and fourth quadrant, if the y value is positive, that means we're going up, so it has to be in the first quadrant, and we would have a point roughly maybe right about here. If you look on the circle, we have a y value at this location. The coordinate here would be square root of 3 over 2 and 1/2. And we're concerned about the y value, which is 1/2, and we want to know what angle is this occurring at. Well, the angle would be simply either pi over 6 in terms of radians, or we could think of it in terms of degrees, which would be a 30-degree angle. So here the answer would be the arc sine of 1/2 is equal to pi over 6 in radians, or the answer could be written as 30 degrees. So notice how this again is different from what we did in the past. When you use the arc sine or this inverse sine, realize that you're given this ratio that we talked about for the sine, whether it's the y coordinate or the x coordinate, and we're looking for the angle. Whereas before, when we took the sine of an angle, we were coming up with the y, the x, or the whether it was the y over x for the tangent, or x over r, y over r. But in this case, we're actually trying to find the angle. So that's one way you know that you're going to have to use this inverse sine or arc sine. The only time you're using these functions is when you're looking for the angle.